Part B, polarity of molecule. For a molecule to be polar, we need to have two conditions that must be applied. The molecules must contain one or more polar bonds. That means it must have the polar bonds. And then the shape of the molecule must not be completely symmetrical. So let's take a look for the carbon dioxide, CO2. Look, you can see oxygen, in fact, it has a higher electronegativity. It should be, according to the value, it is 3.44, while carbon is 2.55. That means here 3.44 and then 3.44, while carbon is 2.55. However, because we say that it is symmetrical, that means it is linear shape. The shape for the carbon dioxide is linear. The ability to draw the electrons to the right is the same as the ability to draw the electrons to the left. So, as a result, the overall electrons, we say that is not almost cancel each other. If the bonds are arranged, the polar bonds are arranged symmetrically, the polarities of the polar bonds cancel out each other. So that means the force, just like the force, it's balanced. So they balance themselves. As a result, the molecules are non-polar. That means imagine the electron is being pulled to the left-hand side and then to the right-hand side with the same force. And finally, electrons will be stationed in the middle because it is experiencing the same force. Just the same case for BF3. For B, boron, we can see that it is 2.04 while fluorine is 3.98. So this is 2.04 while fluorine is 3.98. As a result, fluorine should draw the electrons like this way, the three parts. One is to the right, one is to the left upper corner, one is to the left lower corner. Because it is arranged symmetrically, the force finally they cancel out each other. We will use the term the polarities of the polar bonds cancel each other. So this is a very important sentence. The polarities of the polar bonds. You don't need to mention about the dipole moment, but you can just write the polarities of the polar bonds cancel each other. So the molecule are non-polar. So how can we make it to become polar? We can see the shape of molecule must be completely symmetrical. It must not be completely symmetrical. For example, H2O. You can see the electron is drawing to the upper one. So that means it has a resultant electron migration to the upper part. Hence, we say that this one cannot cancel the polarities of the polar bonds. Hence, it is the polar molecule. Now, finally, you may find it difficult to think about, what is the values for the electronegativity? Now, in general, the electron, the power for attracting the electrons across a period is getting higher and higher because the number of protons is getting more. As a result, it is more easier for the atoms to attract the bonding electron. While when you're going down, for example, fluorine, chlorine, bromine, iodine, the electronegativity values is going less and less. The values is decreasing because you have more electron shells. If you get more electron shells, that means the protons is further away to the outermost shell electron. As a result, iodine has more electron shell, and hence the ability to attract the electron is lower than that for the fluorine. So you may do classwork and then just try these two